this computer. There we go. Now we're recording. All right, 8:01. We'll start officially in a few seconds.
Oh, it's a backup. If I move it to the other slide, it'll work. Yeah. Yeah, it's a good work.
Okay.
Hi, Wade.
This is fucking
What?
bad.
Did you say Wade? Don't tell me he's lurking in here too.
He just jumped in.
Okay. Hey, I have no problem with everyone keeping their microphones on, as long as they're like relatively quiet in the background or whatever. Or you can feel free to mute it. And if you want to unmute yourself and ask a question, I'm good with that too, because I want to consider this kind of like a small group training thing, basically like a classroom. So if you have questions, just jump in, ask the question or get my attention or whatever. And I'm sure if I don't remember where I was, there's enough people here to remind me where I was when we cut in from something else. So having said that, let me start off here. This is the first time I'm doing a 10-foot box presentation. I know people have been bugging me for years to do this, and I finally said, okay, I'm just gonna schedule it and do it. So here we are. And this may be the only one, or this may be the first of many. I have no idea. I guess we'll see where it goes.
So you'll be doing it again for
I'll be
name
doing
bars.
it again, right? No CEUs on this one. Sorry, guys. All right. Can everybody see my screen share? I hope. Is that like everybody seeing
Yes.
a couple squiggly lines and what have you? All right, good. This is from the ACTAR test prep groups file section. Is part 2, practice problem number 2. That is the tire marks from the diagram that you would see and be given something similar to that in a test scenario, I'm thinking. So given that to start with, I'm sure everybody here by now knows that the ultimate goal is to plot vehicle final rest positions, plot any as close as you can get to maximum engagement, approach paths, and so on and so forth. Ultimately, you want to get square root 30 DF on the departure path, so you can get departure speeds for each vehicle and departure angles. And that's what we're here to talk about tonight for the most part, is getting the departure angles. That seems to be so problematic. And some of the finer points on maximum engagement, separation point, so on and so forth. So let me add to this diagram. This is the Dart and the Durango practice problem. I forget which one smacked into which or whatever. As a matter of fact, I think this was from Rex, the last Rex, not the most current one, but the one before. I think it was a crash that Brad Muir and Greg Russell did, and I glommed their data, or a lot of their data, from that, and created a practice problem from it. So let me first off, I'm going to jump in and add right off the bat the traces for the center, the paths of the centers of gravity for the two vehicles. And I'm going to start there because I'm hoping that everybody, at least who's here tonight, knows how to get, let me dial it back a little bit, knows how to get this much, because that's, of course, that's critical. The first step in getting a departure angle is you got to have the path of the center of gravity. And so going back a bit, when I did the test, and I'm not sure how many people do it the way I did it, personally, I like to start from final rest positions and work backwards to where the collision occurred. For me, it's just easier to plot the center of gravity path backwards for some reason. I don't know why. It's easier for me to keep track of which tires go to which marks, that kind of a thing. But ultimately, you're going to wind up with a diagram like this, minus all those little plus marks you see on my center of gravity paths. And what those are from, when I ran this practice problem through a simulation, either McHenry's simulation or RecTech, I forget which one now, but I took the output of that simulation and asked it to give the output to me in 0.033 second intervals. So that's like 30 frames per second intervals. And that's basically what you'll see, those little black tick marks. Okay, that's every 30th of a second as the vehicle is approaching. And you can see it goes from a pretty much consistent speed before impact. When we have impact, it slows way down. The plus marks get much closer together because the vehicle's not traveling as far between each 30th of a second. So after doing a boatload of these kinds of crashes in simulation programs, and once you do it in a simulation program, it's like super easy to ask it to plot the center of gravity path. And I started looking at these and I'm saying, wow, we all sort of kind of know that the exchange of momentum or the duration of the crash pulse or the collision is on the order of 1/10 of a second, give or take, 80, 90, 120, depending on the vehicles, somewhere around 1/10 of a second. So for 1/10 of a second crash pulse duration, the way I have things laid out here, each interval, let me use my pointer instead of my fingers so you guys can follow me. Each interval between plus marks is roughly 0.033 seconds. So 3 intervals, 1, 2, 3, or 4 tick marks, basically, three spaces, 4 tick marks, that's 1/10 of a second spacing. So when I started to look at that, I'm like, whoa, we can see that, here's the approach path for 1, within 3 or 4 tick marks, the whole thing is over, and we've got our departure path defined at that point. So then I said, well, if it's that close together, right away, I could tell people, and I'm not sure where or who or whatever, people are still picking up departure paths. I would hope everybody knows by now, you don't go from somewhere where you think maximum engagement is or separation is to final rest position. On occasion, you might get it, you're lucky if it's like a dead straight path for the CG from separation to final rest. That hardly ever happens. I don't know if I've ever seen it happen, but that's not the way to do it, because really you want to get the departure angle measured right where the collision is over and the momentum exchange is done. And I define momentum exchange as either the vehicles have separated, so they're no longer working on each other, or they're both completely entangled with each other and both center of gravities are moving off in the same direction at the same speed. So there's no more momentum being exchanged because they're both going same direction, same speed. And I'm going to go out on a limb here and say that probably does not happen on an ACTAR exam test where you get both of them, going off at the same direction, same speed. I don't think. Maybe it does. I haven't seen that. So anyway, so I started to think, okay, if we can say that this is a good illustration of how quickly things happen, like 4 tick marks, 3 intervals, the momentum exchange is done, and from approach to departure, if I look at this line segment right here, or this one right here, the green one, that's my departure path. That's my departure angle right there. The vehicles are still moving with enough of the direction from the collision force that ground effects have not taken over, which is one of our big assumptions for doing a conservation of linear momentum analysis, is that the ground forces can be ignored for what we're doing. So I said, okay, what's the best way to hone in on how to get people to follow or to get that departure angle rather than just trying to describe it in words. And that's when I came up with the 10-foot box method. And I said, okay, if I look at the tire marks that we have to deal with, and I take a broad range of vehicles, whether it's a crew cab pickup truck or a Hellcat, I don't care what it is, odds are pretty good I can fit the tire marks from the collision from one vehicle into something that's 120-inch wheelbase or smaller. So that's where the 10 feet came from. 120-inch wheelbase maximum for the most part. Most everything's going to fall in that box. So let me bring in the 10-foot box for the Dart, and we'll just look at that one for right now. So the approach path, what I do is I take the 10-foot box, and I do the best I can to take my 10-foot square and get the four tire marks, from where I'm sure the vehicles are engaged, because if they weren't engaged, I wouldn't have tire marks. So at the earliest, like at the onset of my tire marks, that's where I put the 10-foot box. And the path coming into the 10-foot box, that's my approach angle. And the path going out of the 10-foot box, whether it's on the opposite side, the left side, the right side, whatever. That's where that center of gravity path exits that 10-foot box. That's where the departure angle is measured. You don't need to go out any further than that. And it's just that simple. That's how I describe it. I don't move the box. I don't move the box around. I don't draw any lines from where maximum engagement is or where separation might be. I just look at, okay, here we're like 30, 60 milliseconds after the momentum exchange, and my departure angle is defined. Again, same thing. Let me bring in the other one, the Durango 10-foot box. Again, let me turn this one off. Dart 10-foot box. Okay, so now in this particular problem, I've taken the green is the Durango, and so the Durango got broadsided in this one, and that's the tire marks being pushed to the side. So I know sometimes you don't have all 4 tire marks, sometimes you have 3, sometimes you have 2, whatever. You got to do the best you can trying to figure out where that vehicle was, given the tire marks that you have to work with, and just put your 10-foot box on that. So, whoops. So on this one, the Durango approach coming in, it's not horizontal. This was like, whatever it was, 105 degrees, 95 degrees. I can't remember where I took 0 on this one. But you have the approach angle on this side, and the departure angle is on the opposite side. So basically that's all there is to it. I mean, other than the other thing I probably should mention is, let me bring in protractor here. Okay, once you have your protractor on your drawing, okay, whatever you do, however you decide to orient your protractor, 0 is going to be 0 throughout your whole analysis. I'm basically lazy, and I like to do the math as easy as possible. So I try and move things around, twist things around, so I get everybody going off in the first quadrant to make the math a little more simple. You don't have to, but that's force of habit. I guess I turn my diagram and get things organized in that fashion. So once you get your protractor on, do not dare do any of this. No rotation of the. Oh, did it rotate? Oh, I'm probably locked on. Hold on. Do not dare.
Huh?
There we go. None of that. Don't
Zoom
rotate
thing
the,
on
what's that?
accident thing.
Don't all you gotta do is translate your protractor around. Do not twist it, turn it, keep zero facing the same direction at all times, and line it up. Extend your line so you can hit the sides of the protractor or whatever. But that's all there is to get the departure angles. Now, surely somebody must have some questions, because I know a bunch of people have said to me, suppose I do this, or suppose I do that, or how do you do this? Or does anybody here have questions, or is there something I missed? That's why I wanted to have an open conversation. Hopefully somebody will say, but wait a minute, George, what about whatever? Or is it completely 100% crystal clear at this point? Anybody?
Check the chat, my friend.
Oh my God. Check the chat. You guys are killing me here. Oh, can I show the cars in that diagram approach an FRP? No. I got, let's see, I can put the final rest positions in, but I haven't done them on, at least not in this one.
So my guess is that a bunch of people would probably like to see how you get those lines if you don't happen to have a simulation program.
Well, that is another topic. I mean,
I know how I do it, but
yeah, I mean, that's starts with making your little clear plastic template, and literally putting it on the tire marks, and your push pin and pinning the center of gravity as you trace the tire marks back toward where the collision occurred, or if you do it from the collision out, in the other direction. That's I didn't think that was as much a problem as where do we get the departure angles from? I could, well,
so I'm with you. I actually brought transparency page and a pair of scissors
yeah,
to the test, and I drew my little scale cars and put my little scale tires on there.
Yep.
And found my CG and cut a hole. You talked about using a pin. I like that one. I actually just cut a hole so I could poke a pencil through the hole at the CG,
yeah,
and draw a line as I moved my little scale transparency car model across the tire marks, draw the line. And what I found in having done lots of these over the years, like you, is that in the first, and it turned out to be about the first 10 feet, usually the first half second, three quarters of a second after impact, the CG moves in essentially a straight line before the tire forces begin to really redirect the chassis. So the chassis gets pushed around by the impact and redirected. You get this straight departure area, and then the tire forces begin to act, and then curvature starts. And with the transparency plotted in place, you see that CG path that goes into and out of the impact. There's a bunch of uncertainty right in the middle because, who knows exactly, right? But you can get close once you've got good tire marks and follow that CG path. It'll be straight for the first 10 feet, 15 feet, half second. If you're going 30 miles an hour on departure, that's 44 feet per second. So a half second of that is 22 feet. So that's even a little bigger than your 10-foot box.
yeah.
But I think that was important for me. I wound up seeing that worked okay for me because I wasn't using a simulation program. I was working with my little hand diagrams.
Yeah.
And I wasn't confident about my directionality in the first 10 feet. So I generally used a little longer, but not much.
All right, there's at least a somewhat scaled Dodge Durango dropped on. So what basically the way to saying is you've got to generate this guy right here. Based on the vehicle specs, you take your little transparency. You have to plot where the CG is, you know, compared to where the front and rear tires are. And literally take the tires and drop them onto the tire marks. You have to figure out which tire mark corresponds to which tire. And I'm hoping everybody here is got that down pat at the very least. I know years ago at the annual conference, a group of us down in Maryland probably combined 200 years experience reconstructing accidents, and we got to watch the crash happen, and 5 of us were like, which tire mark on the asphalt? How can that be? Oh God. And we watched the crash happen. So, you know, that might be the worst part of setting up your problem. And I think the first hour of the exam, you can burn the first hour making your little transparent cars, and getting them on the diagram and plotting the CG path. That I think might consume the first hour, believe it or not. So, but anywho, that's the same thing. Let me copy this. Get another one over here. Facing this away. Yeah, it's nice when you have a simulation program to do all this. And I'm so happy that I passed the exam and don't have to do it by hand anymore. Even though many times I still scribble on a pad before I'll even fire up a simulation program or anything, just to get my brain wrapped around what the heck is what with a scene or whatever.
George, I have a question for you if you got.
Good, I'm ready.
So when you're first setting the box, just can you maybe just go over again? We were saying where the tire marks first begin, you're trying to get all the marks that you do have for that vehicle still inside the box, but as close to the edge without anything going over. Is that pretty much how we're setting it there?
Yeah, let me bring back the Dart 10-foot box and show you guys. I mean, when I first started doing this, literally what I did, I took the 10-foot box and I said, okay, here's the tire marks, you know, that's the right rear, left rear, and the front's for the Dodge Dart. So I took the 10-foot box and I kind of centered it up on the approach path, and then I literally slid it up until I got as much of the tire marks in there, you know. So you've got on your scale diagram, that's a 1-inch square. So you just literally slide your 1-inch square around. I did it kind of centering up, you know, centering it up on the approach path. Come on. I don't know if it's hypercritical that you do that, because to me, if the box is off a foot or two, as long as you get the 4 tire marks or as many as you can reasonably get in there, that's all you need to worry about, you know, I think.
I would suggest bringing one of those templates with squares and circles in different sizes so that you can easily have a 1-inch square to look through.
Yes. Yeah.
George, how did you pick your approach angles there?
I think that was like a given in the problem for this one. Like one was going north and one was going, you know, 5 degrees or 10 degrees off of west or whatever. I don't know. You guys could probably tell me. I don't know how they're doing it now on the exams. If they're giving you that, or is it like, do you have to start plotting pre-impact skid marks to get it, or is it given in the setup for the problem? One northbound, blah, 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 one westbound, yak, yak, yak. I don't know. Does that
They
still,
give you skid marks.
you have to start plotting?
Yeah, you gotta plot pre-impact skid marks, which, I mean, once you get that, it's easy. It's right in front of you. The approach
Okay.
angles, once you have those, is simple. It's the departure that has eluded me.
Okay. What about, I know when I took the test, it took me a long time to get the diagram coordinated with the chart of measurement data. And the reason for that, I thought, was because the reference point, I thought was like an ink dot, like a mistake on my drawing that they gave me. I thought it was like a random ink dot. I didn't realize that was the reference point, because it didn't, there was nothing, it wasn't a cross, it wasn't anything. So are they doing better now with reference point? Can you at least identify the reference point on the diagrams that you guys are given? Is it somehow?
Yes.
I would say yes, yeah.
Yes.
But they don't tell you what the orientation is. They don't.
No, but at
Yeah,
least you know where the
like
reference
that.
point is.
Yeah, they'll give you a little cross like you've got here. That's,
Okay.
I mean, it's obviously identifiable.
Oh, okay, good, good. Because on mine, it was just like a dot. And I was like, it sort of kind of looks like that's where the reference point should be. But I probably burned 20 minutes deciding that that was the reference point. Oh my God.
Yeah, you're right. You'll burn a lot of time plotting the pre-impact skids and drawing those. And then, I mean, you waste an hour before you know it.
Yeah, it goes by real fast. It goes by real
Then you get clammy hands and you start getting nervous and all that fun stuff.
Well started is half finished.
George, I have a question.
I'm ready.
You're assuming in here, and because you have a simulation program, that you are able to get those dots in time intervals. Remember, in the exam, we don't have that. The time is not a variable on the exam.
Right.
They gave you this tire marks, and what you're assuming here is that you are able to plot those, the center of mass following the tire marks. I'm not sure whether on the exam they always give you all that data, or whether you only have 2 or 3 tire marks and you don't have all 4, because here you are assuming that you have 4 of them.
No. Like even this one, to get the Durango out where it wound up, there's no tire marks.
No, I'm not talking about there. I'm talking about where the box is. You are assuming in both of those boxes that you have all the tire marks for all the wheels. And I'm not sure that in the exam they give you all of them.
No, you're probably right. But if you have 3 of them, or even if you have 2 of them, and you know the approach, angle, that should at least tell you where the tires are at the point of impact.
George, if I could throw in, you
Yeah.
have to consider damage matching as well. So you've got a car coming north and a car going west-ish, but they're going to give you some information about the cars or pictures or something so that you know if the red car hit the side of the green one or if the green one hit the side of the red one.
Yep.
You'll have some idea whether the front left tire or the green one is in the middle of the front bumper or if it's near the corner. So you have to line up the cars kind of sort of at impact to start to get an idea of how to line these tire marks up, right?
Yeah.
Well, that's another question there. When you say at impact, whether that, my understanding is at impact means at first touch. But if at impact would mean at maximum engagement, then that would be one of those points that you want to use. So my question to you would be, how do you determine that? Because to draw the line, you at least you need 2 points. So I would like you to clarify that. How do you get those 2 points?
Oh, okay. No, Jose, what I was going to say, they certainly don't give you any time information like where you see these tick marks. But to me, I could take the tick marks completely out of this diagram. And it doesn't make any difference because the only thing I'm looking at is where the tire marks start. I try and put the back end of my box as close as I can get to those tire marks. Or if I only have front tire marks, I would put the front of the box at the trailing edge of those tire marks. So I'm attempting to fit where I envision the vehicle when it's making those tire marks. When it started making those tire marks, I know they're engaged. There's no doubt about that. So, and that's why I like the 10-foot box, because I think this is what Wade was getting to. You start to realize after a while at the speeds that we're dealing with, like they're not coming in at 80 miles an hour for an ACTAR exam problem. I don't think I've seen one like that. So, but at the speeds that we're typically dealing with on the problems, specifically the problems we have to work with for an ACTAR test exam, you're within 5 or 6 feet of where that collision occurred, it's going to be exiting that 10-foot box. So I don't need 2 points. At all I need to do is look at where the departure path exits the box, and that's the direction right there. That's the only angle I need. I don't need to draw a line segment there. The path will do it. Unless Jose, you mean I have to get 2 points, one on each side of the box perimeter, I guess is what you mean.
No, that's not what I mean. When you use the word path, it means you need at least 2 points to draw that path, if not more.
Right.
So the point here is, if you are going to be tracking the center of mass, then obviously that's one method that they teach in, even the Northwestern teaches that. But if you're going to use this method, you got to be able to know what the difference between the two are, because based on your explanation here, you are basically tracking the center of mass. And so what I was trying to say is, how do we know how many points do we put together so to make that line so that we determine the angle?
Okay. I think for every problem I've ever done has worked out about the same as this. The path can get squirrely toward the end of the path, but the closer you get to where the collision occurred, it straightens out. And as you exit the area of impact, it stays straight until ground forces take over. So at some point, as I'm getting closer and closer and closer, that line begins to straighten out tremendously. So I don't think it makes a difference. I don't need 20 points in that first 10 feet. If I get 2 or 3 or 4 points back to where the collision occurred, and that's generally where the tire marks are going to be, I think I'm in good shape.
In both of the examples that you have there, at some point, the path changes from the approach to the departure. That point has to be either the separation or the maximum engagement. Is that correct?
Well, it's going to be more than 1 point. Maximum engagement is going to extend for a finite amount of time. So it's not like a point.
In your boxes there, you have 1 point in which the path changes direction. So I'm asking you, is that separation or maximum engagement?
Well, it's not one point where it changes. That's what I'm saying. It's a gradual change that occurs over 2 or 3 points.
George,
Yeah.
could I try?
Yeah. Go ahead.
Jose, the place in the middle where the path changes direction, ignore it. It is chaos.
It's
Okay.
chaos.
And we do not have enough information to ever get that little teeny bit of angularity change in that
Okay.
sort of resolution. What matters is the angle of the line. George has shown it about 5 feet from where that starts, right? From somewhere near the middle of the box.
Right.
And I've said that it's, and we can see on the red line, let's look at that red line. It's coming in where it crosses his 10-foot box early on, coming in. for the moment, let's assume that the problem has some skid marks or car driving north, or there's something in the problem statement. So you know the direction coming in.
Mm-hmm.
On the way out, take your little model car and plot it. And that's exactly all this program has done. They just plotted it 40 times, when I think realistically, if you plotted, you take your little diagram car, your little plastic one with a hole at the CG, and either push a pin through it where one of those dots are. I just moved it a teeny bit so that all the tires lined up on the marks and made a dot with a pencil, and move it a teeny bit and make a dot with a pencil, move it a teeny bit, make a dot with a pencil, make it. And by the time I got back to somewhere close to the area of impact, you'll see that straight line. And in that red line, we see there's a straight section for about 12 or 15 feet after the impact. The chaos part, ignore it. Maximum engagement, separation, ignore it. We don't have the tools to be able to identify those things, but
Yes.
we can identify that path of travel, that direction of the line in that 10 or 15 feet after impact. And that's where it's crossing his box. So it's the direction of the line is all that matters. What's going on in the middle kind of doesn't matter.
Okay, so basically your answer would be, if you do the tracking of the center of mass close to where the line exits the box,
Right
that's
there.
what you need to, yeah,
And
right
I
there.
think I would say that if you track this car, this red car, you place it at final rest, and you'd put a dot at the top part of that line, right, where there's a big cross right now,
Up
and
here.
then start backing it up. I'm like George. I start at the end where I know something and I figure out what I can deduce from that. So as you move that car back, you would move it back a little and put a dot, and move it back a little and put a dot, and move it back a little and put a dot. And you would say, oh, that's curving.
Yeah.
That's not going yet back to where these cars really met. So keep going, put a little dot, keep going and put a dot, and keep going and put a dot. And oh, it's still curving. Keep going, put a dot, keep going, put a dot. And then, oh, look, it's starting to get closer. Keep going, put a dot, keep going, put a dot. Another one and put another dot. And then you start to say, hey, these 3 dots are in a line.
Right.
And then there's 3 more that are in a line. And then they point right back at the area of impact, which is now very close. That's my line.
Okay. Okay. So
George?
basically going backwards is what you suggest.
Yes.
That's the way I do. I don't know if everybody does, so that's the way I did it too.
I honestly don't. I think otherwise you're guessing, you might hit it right. But if you're trying to guess tire marks from the start to the end, I pretty commonly use my car models to set them over my tire marks to get a sense of, okay, I think I know which tires these are, and then work backwards from the end to make sure that I'm right. Or sometimes to say, oh, you know what? I think that's actually the other side. Whatever.
Right. Yeah, I just thought that because they give you the profiles of the deformed cars, I thought you did have to get the maximum engagement point as a reference, but what you're saying is may or may not work, but if
Well,
you,
I think that-
if you discover
I
the
think that
straight
will
line, then
help
you're
you.
fine.
I think that will help you identify how the pieces fit together.
Mhm.
But I'm with George. I would start with the end and work back towards what I don't know, not guess at what I think I know, and work forwards to what I already have.
Okay, very good.
The other.
George, somebody asked about the post-impact distances. Do you want to give a 3-minute spiel on that?
That's exactly what I was going to hit on next. Because to Jose's point about whether it's separation or maximum engagement, you still need to not only get the departure angle right, but you need your post-impact travel distance. And that's where it's going to come into the separation. And I think when I did a test, I think I might have plotted, like Wade is saying, pick a point, I might have done the departure path like in 1-inch intervals or thereabouts. Because over like a 1-inch, each 1-inch segment was relatively straight. So, but ultimately you're going to need the distance from, let me get up here, from the CG's final rest position back to, I would say, separation. And separation is going to be where this straight path basically begins. Now,
And that's where the damage profiles help you, because you can see how
Exactly.
far each car intruded into the other.
right. And at this point, you know, if it's a 20 or 30-foot run or more, you know, you're going to be looking at a straight line coming in and another straight line coming in. You can kind of fillet those two, basically. You know, draw a little fillet in there, and that's as close as you're going to be able to get to picking that separation point. You might be off 6 inches. I'd be willing to bet if you do that, 6 inches to a foot is probably the worst you would be off on your distance. Because it's going to be somewhere near the center of that box, but it's going to be at the end of, or the beginning of, I guess, depending on the way we're going to travel it, the beginning of the straight portion of the departure path. That's how far in you want to go, back to that point.
I'm pretty sure that I have heard, and remember, I'm not party to any actual ACTAR inside information.
Right.
I know people who are, but I have particularly stayed away from any questions on the topic, but I'm pretty sure that they are specifically expecting you to measure from approximately separation to final rest over the CG's path of travel. So I brought one of those curvy, bendy ruler things.
Flexible ruler, yeah.
So that I could bend it up to track my tire marks and then straighten it out and measure it. It's either that or you measure an inch and then hold the ruler while you rotate it a little bit to measure the next inch. And then you hold the ruler and rotate it an inch to measure the next inch. And, you know, you can do that too, but a bendy ruler worked great for me. One of those drawing aids that allows you to measure a distance or form out a shape, and then you can straighten it out and measure it. But they just want you to do that instead of, say, measuring just the visible tire marks. I
Right.
think that's part of who they're trying to whittle out, is folks who are measuring just the tire mark.
Yeah.
You know, so David has thrown in, let's call it the blue blitz. No. There is a bendy drawing tool. If you go into Staples, into their drawing aisle, there is a flexible, hard plastic. It's usually square, so it'll lay flat on a piece of paper, but you can bend it into any shape you like.
Yeah.
And then straighten it out to put it on a ruler.
It's like
So
lead lines.
it's not
so
the blue
wherever you
blitz.
bend it, it stays. The blue blitz, I know the guys that use the blue blitz, they'll bend the blue blitz to try and match the curve. But I think that's more difficult. Like what Wade is talking about, it's a flexible ruler that once you bend it, it stays bent. It's like a lead lined flexible ruler. It doesn't spring back. So wherever you bend it, that's where it stays. And it's millimeters on one side and inches on the other. I know that's the one that I got.
I wound up using the millimeter or centimeter inches as my way to scale out things. So when I was doing my diagram, I used centimeters as a scale. I don't know, it worked out good for me, but you know, practice your scaling, practice your drawings before you go.
Yeah.
Have a plan, bring your transparency papers and that bendy ruler and and a blue blitz, because there are sometimes things that are helpful there.
On the practice idea, so I don't know how often we get the chance to actually talk to the guys. The guys, when I did a prep class, we worked through 2 or 3 or 4 practice problems. By the time they did their third full-blown practice problem, it was like, oh, can I use this for my test? Because you get so used to like the routine of how to do it. It becomes like second nature. You just got to do this, and then the panic is gone because you know your own timing and so on and so forth. So I got to tell you, this is one test that practice will absolutely positively, even if you are aces at knowing how to do it, the practical skill of doing it is going to come in very handy. You got to do practice problems, not just read through them. You got to like work the practice problems, and then you won't be sweating it at the test probably. So, did you say David had, where is anybody else? Oh, wait, holy man, we got 9 questions in chat. Or is that all you, Wade?
It is not all me, I swear.
Let's see, who did I miss here?
Oh, so the one we're missing so far is a question about where to put the 0 line on the protractor. If you're going to try and chase this as a first quadrant, I would rotate the whole thing 90 degrees clockwise.
Yeah. I know I wrestle with this. Sometimes I do my 0 line north, sometimes I do it east, sometimes I do things clockwise, sometimes I do them counterclockwise. It totally depends a lot on what kind of data I'm given sometimes. But as long as you're consistent throughout, that's the key. And again, let me pull up.
And I would throw out, in order to be consistent on that count, I would be inclined, and personally, I make a note on my diagrams when I'm doing that kind of stuff, that I'm going to measure clockwise this time. So I've settled on using the 4 angle equation rather than the 2 that require me to pick a 0. So I always just have 0 is east because it's easy for me to read and remember.
Yeah.
And I just use 4 angles.
I would definitely draw on my paper 0 and an arrow for where's, so I don't have to think about it, you know, oh, did I do it this way or that way? For the test, I would absolutely put a 0 and a 90, so I don't lose track of where I am or start doing things the opposite direction, or I get confused. Put a 0 and a 90, and that'll help you keep track of what your plan was, at least. Yeah.
Would you be able to draw on this, the approach and departure angle for the for the dart, just to give a visual how to
Oh.
really put that box to use?
Let's see, dart departure angle. Here we go.
Or possibly queue up the markup option.
The markup. Oh, you mean for the
Yeah, and then everybody can put their own 2 cents in
oh my God.
on paper.
Is that the annotate copy here? All right. So we declared this as, oh my God, 0. So roughly here, that's my departure angle for the dart. And 23.05, you know that's not me and pencil and a protractor at a test. That is the simulation program telling me that one. Oh man. So now the let's go.
And you're centering the
Use the color
protractor where those lines intersect.
Run that by me again.
You're centering the protractor where the lines intersect.
Negative.
No,
Negative?
I'm taking, well, let me do it this way.
Put your protractor back up there.
All right, let's get rid of clear.
Because there is a line already from your drawing program for the approach.
Yeah.
So remember that vectors are not located on the earth. You can move, when you're measuring the angle for a vector, you can move that vector all around the place, anywhere that's convenient.
Okay, so I'm declaring, let's do it this way. Let's draw a line. Let's get rid of my lock here.
See, I would have rotated the paper counterclockwise. You rotated your protractor, or you rotated your protractor counterclockwise. I would have rotated the paper clockwise. Either way, it's the same thing.
Okay, well, I'll use the 0 on the inside here on my protractor, let's say. So let me draw a line first. Well, you guys are really testing my skill set here tonight. Let's go from this one to, well, let's go down here. Okay.
There we go.
So now I got a line, that's in line with my departure path, let's say. And let's go, let's extend that down a bit further. Edit. Trim, extend this guy down to there. No. Okay, made it a little bigger. All right, so now, did I lose that? I think I'm still on the same. Hold on.
Just extend that upper left corner.
Yeah, I think I'm twisted it.
Yeah, that was me in crash zone every single day.
Yes, oh my God. Let's go down here. Okay, so there's the angle of my departure path. Everybody good with that so far? And 0 is essentially straight up. So let's draw another line down here, anywhere, doesn't make a difference. Straight up. Okay, so my departure angle, 0 is straight up. Let's bring my protractor down.
So you might want to show that you can just put the center point of that protractor on your line anywhere, as long as the protractor is facing the same direction, and it'll read the same angle. No, it doesn't matter where you put the center, as long as it's on the line.
Yeah. Let me. Why is it locked still? Come on.
No, too much.
That's pretty close.
Yeah, it is.
All right. So of course I didn't make my line long enough up
Well,
here.
just move it down.
Jeez, are you killing me? All right, here we go.
I'm glad I'm not the only one who hates it.
That's better. Now let's get it over here a little bit. That's pretty close. Okay. So now let's blow it up. 0 is straight up north, 10, 20, 1, 2. That's definitely 23.05. I can tell.
I like it.
So it's only, since I declared 0 is straight up, I just draw an extended line through my departure path, and put the protractor on, keeping it 0 north. Good enough? Want another one?
No, before you leave that, now, one of the things that you can do if you want to feel more comfortable about things is put the center of that protractor at the intersection in the lower center where your vertical red line and your angled line are. That may be easier to visualize as a way of measuring the angle, is using that intersection. But you can put that vertical line anywhere you want.
And
It's
that's
still
what I
going to
was
be
talking
23.
about. That's what I was talking about earlier when I said you put it at the intersection where the
Yep.
departure angle intersects the approach angle. That's the way I was taught.
Yep. Well, that's exactly what he's
Okay.
done here. But it doesn't matter if you draw a parallel line somewhere and measure it
Right.
where
Yeah,
it's clean.
That makes it much more clear.
Well, either that or the only thing you have to watch out for, I think in what you just described, you've got to assume that your approach angle is 0. Because if your approach angle is some odd number, if it's coming in at 172 or whatever, that works out great. If your approach angle is 0, then that'll work. I think that's what you said. Uh-oh. Josh, was that you?
But can't you always
Yeah.
make it 0? Just rotate the paper?
Yeah. I like to rotate the paper. It's just
Yeah.
easier for me. But
Which way do you declare 0, Wade? To the right? Or to
well, where you rotated your protractor counterclockwise,
you would take everything and
I would have rotated the whole paper clockwise the same amount. So I just turned the whole paper 90 degrees so that the Durango is, or sorry, so the dart is traveling east on the paper, traveling left to right. But because we're working in paper, right? I mean, you've got a piece of paper on a desk in front of you for this test. All you got to do is turn the page to the side.
Hold on. Let me back it up here. I forgot to lock it first. Okay, now who doesn't love? There we go.
There it is.
That's the Wade method.
Yeah, that would be I would physically turn the paper because we'd
Yeah.
be working with paper and pencil on a table in front of us.
Yeah.
It's easier for me to turn the paper.
So would you mind doing it again then with Durango?
Yeah, I was gonna ask if you could run through the Durango too, but while we're here.
All right. Let's do, we're still going to use a 0 in that direction. Okay. So let's do the Durango. Let's get rid of this lock. Draw a line.
You already have a line, my friend.
What?
Oh, you're going to draw a departure line there?
Yeah.
Okay.
I think that's what we were requested to do.
Yeah.
Let's
Yeah.
go from here. To there, we'll call it. Bring our protractor over. Oh, let's try this. Oh, yeah. Ah,
Fucked it up.
there, that's close enough. Okay, so now we got 0.
So your departure angle is 47,
Yeah, give or take.
6.
Yep.
No, 40, 43.
10, 20, 30, 40, 5,
40.
46 plus a little bit.
Now measure the approach angle.
Killing me.
Come on, you knew it was coming.
All right, let's draw one more. We're gonna have a total mess by the time we get done here. Single, let's go the approach on the Durango.
So to avoid the mess on my hand diagrams, I tend to do each of these little angle things off in their own little quadrant. So I will draw an approach angle and a departure angle for each somewhere else so that I can work cleanly on it. You just have to transfer the lines properly, make sure that you're drawing real parallel lines.
That's close. Let's bring a little.
Move the whole thing up one radius so that we can read the degrees,
Oh
my friend.
God, killing me now. All right.
Can you do a move from center to a point, and that way you don't have to try and guess
I
at the
could.
distance?
If I was really good with this, I would do that.
You can't do that for an hour and a half show, though.
If I was Bobby Clark, I could do it. And by God, he is dynamite with.
Yeah, I've met some people who are really good with this stuff.
Yeah. Okay. 10,
Ding,
20,
ding,
30,
ding.
40, 50, 60, 70, 80, 95. We got them all now.
Well, that was fun.
There we go. And we still have 3 hours to do our calculations.
Lots of
Oh,
time.
okay. All right. Now my drawing's a complete mess. Yeah, I can see. All right. Does anybody else have a question on the 10-foot box method or departure angles? That was really my goal tonight, was to help everybody at least figure out where to pick this stuff, literally where to pick up the departure angles. That was the whole thing. Anybody else? Nobody else has questions?
So I noticed when you were drawing the departure lines, you kind of extended beyond the 10-foot box.
Okay.
Practically during the test, would you just start at the edge and draw the line backwards towards the approach angle? Does that make sense?
You know what I would probably do? I would probably draw a line over a good part of the paper. So I have plenty of room to put my protractor wherever the heck I want, if you follow what I'm saying. Rather than
Right,
jam everything like right around here, if I drew my line from here all the way over to here, and I know 0 is now it's horizontal, I would just put the protractor, the center of the protractor on any horizontal line, and slide it over till I hit my departure angle. Does that make sense?
Yeah, that makes sense. That's
I wouldn't try and work in the area of the 10-foot box. It'd be so cramped. I would extend my line, probably both ways,
right. Gotcha.
and make it easier to use the protractor. Give me a wider field to decide where I want to go with it.
So there was a question about doing secondary slaps or secondary impacts. And if you mean cases where somebody whacks the back corners, they hit the front and get that secondary slap, just treat them as one event. Lump them together. There's actually an SAE paper from 2002 that went through all the math and showed, treat it as a lumped event. It's two vehicles coming in, they work on each other, and then an instant later, they work on each other a little bit more, but then they leave. And you can just treat that as one big chaos in the middle. Look at the incoming and look at the last outgoing value. That would be my take on the answer to that one, George.
Yeah, and I've seen from any number of CBR reports that have captured those two, the initial hit and the secondary slap, it seems to be on the order of 1/4 of a second between the two. So again, 1/4 of a second is 5-6 spaces, the way I have it here. So it's only a few feet away. So like Wade was saying before, if you're on that that straight section of the departure path, that's going to be 10-12 feet out easily from where the collision occurred, you'll be able to pick up after the secondary slap. I don't know. I think it would be tough by hand to do that on an ACTAR test. I mean, to pick up the first one, the second one, and make the distinction between the two. I don't know if you'd be able to do that. You'll have evidence. So you look at the photos that they give you to look at the damage profiles of the vehicles. You'll be able to look at it and say, yep, there's evidence of secondary slap. But being able to plot it, given what we're given to work with the little cars and the pinpoints, I don't think you'd be able to accurately diagram that. I don't think.
And you don't need to.
And you don't need to, right? Right. Okay.
Dude, you covered a lot of ground.
I know.
Good job.
Thanks for chiming in here. If I'd known you're going to be here, I would have made you co-host. You could have done the background. You could have done the drawing in the background while I blabbered on.
Watching me stumble around on the drawing probably would have been more amusing than watching you. You're doing good.
All right. We got another chat, or as I keep going back. Thanks, George and Wade. Okay. I am going, if nobody else has any questions they want to jump in on and then verbalize, I am going to stop recording. Let's see.
Thank you, gentlemen. This is very helpful.
Well, we try.